Great. Thanks, thanks very much, Sarah. I'm going to just talk for a few moments and then I'm going to add my slides. So just want to say a few words. So I am an earth scientist by training and by inclination, but for the last probably 20 years, I've done all sorts of other things, including some earth science. Fortunately, I still get to look at rocks. And so I've been involved in innovation, sustainability, and a lot of the topics that Sarah was just talking about. Thank you very much, Sarah, including cobalt. So that was I didn't ask for that. So thank you very much for that quick mention. And I've done that in academia, 3 universities and a couple of major companies and a lot of other companies. So I generally tell people that I'm still trying to work out what it is I want to do when I grow up. And hopefully it'll become clearer at some point. But in the meantime, I have a lot of fun. This time last year, of course, we were doing this. We were part of this amazing conference. At least I was, not all of us, but I was very fortunate to be part of it. And for me, it kind of set the bar for virtual conferences. I mean, it was one of the first, certainly it was the first one I think I was involved in, and it set the bar for virtual conferences. We really didn't know what that was at this point. And perhaps for me, more important than the conference was it set the bar for discussion, virtual discussion. And that was a very neat concept that many have replicated, but perhaps none quite as well as Sarah and team did right at the outset. So congratulations to you for that and for doing it, for risking doing it again, and this time with a lot of competition. You know, there's a lot of other things. Sarah and I were talking earlier, there's a lot of other events going on right now around the world using this medium. So today, what I want to do is I just wanted to think back on where we were this time last year. And as I thought about that in the context of this conference, there was tremendous uncertainty. As Sarah said, many of us were in lockdown then. Some of us still are in lockdown now. And we didn't know at that point where things were going. There was uncertainty around the industry, around metal prices. No one knew exactly what was going to happen, whether people were going to do any exploration at all. And there was massive uncertainty, I think, about ESG. People were very concerned as to whether it would just slip off the agenda. You know, there would be so much concern and other things happening in the world, difficult issues that we were dealing with, that ESG would just, slide off the top spot and perhaps would disappear off the profile for many companies. And unfortunately, that turned out not to be the case. In fact, many things turned out not to be the case. Many of our worst fears were not realized, which is a good thing. For us who are fortunate, obviously many unfortunate people didn't fare so well. But for the mining industry, the metal prices came back, things recovered, and ESG not only was there still, I think it continued to rise in importance and it received more and more attention, as did climate change. And so climate change did not fall off the agenda. In fact, quite the reverse. It's absolutely there, front and center. So again, as I thought about this, I thought, well, what encapsulated to me some things around ESG in the last year? And there were 3 things that really hit home for me, and to some extent that I was involved in. So it's these 3 things that I want to talk about very briefly this morning. So I'm just going to share my screen here, all being well. And now you should be seeing a wonderful picture, or not so wonderful picture, actually, of Brumadinho, a disaster of unmitigated significance for everybody, and especially for the many people who lost their lives in that event. And this has been discussed a few times in this conference already. It was a wake-up call for the industry, and the net result of that was these 2 volumes which are on the left side of the screen here that were released by the 3 partners, ICMM, UNEP, and PRI in August 2020. And these were massive collaborative efforts. They took 2 years, more or less, plus or minus, to produce, and Tom Butler would know more about the exact timing than I do, but I got involved relatively late in the piece. But it was an extraordinary effort by a lot of people to really think this through and produce the global industry standards on tailings management. And alongside it, the Towards Zero Harm, which was a compendium of amazing papers that go into great depth on many of the issues. And you can see here on the slide what this amounted to, 6 topic areas, 15 principles, 77 auditable requirements, etc. So that's a fantastic, fantastic result and a fantastic effort, fundamental to a big part of ESG. And these are just a couple of slides from a couple of the papers in that compendium. The one on the left just illustrates the problem. And if you look closely on your screen, you can see the size of the many zeros behind each of those numbers. That is 72 billion tons of waste rock in 2016. That was 1 year. That is 8.85 billion tons of tailings in 1 year. And this is the scale of the problem that we're talking about. Massive, massive issue, massive, massive challenge. And on the right comes from Angela Kupper's work. And this is a diagram that just demonstrates that while tailings is a technical problem, and we had some discussion around the technical challenge of upstream tailings dams and so on, it isn't just a technical problem. It's part of a very complex system, complicated and complex, a complex system which is within the context of an operational mine and the people who live around that mine, the communities and everybody who's involved and potentially affected by a tailings dam disaster. And we need to treat it as a system and understand it, because verifying, implementing and verifying change in tailings isn't going to just be an engineer redesigning a new tailings dam. It's going to be a lot of thought about what tailings are, how we can reduce the amounts of tailings we produce, how we can look at different ways to manage tailings. And all of that plays into the economics of the mine, the processing of the mine, the nature of the rocks, et cetera, and all the people involved in making the decisions. It truly is a complex system. And if we're going to address it, it's going to take a lot more work in the future to build on that great starting point of the standard. So the big question that remains is implementation and verification. And will we actually see real change in the coming years? Hopefully, it's worth remembering that we had a disaster, a massive tailings disaster, almost every 2 to 3 years for a number of years. And so we hopefully, as we go forward, we won't be seeing that again. So I'll go to another very topical issue. This is the iron ore, the destruction of the heritage going to the PKKP in Western Australia at Juuken Gorge. And again, other people have referenced this, and it may receive more comments as in the remainder of the conference. But I just want to put this in the context of iron ore. So it's worth just thinking about what it is that this is all about. It is, for the mining industry, all about iron ore. And in 2020, this time last year, on this slide, you can see the prices in April last year were $85 a ton. But by May, by the time of this conference last year, they were beginning to rise. They're up to $94 per ton. By today's prices, actually, I wrote this last night, $230 a ton. I just noted that it's $237 today. The cost in 2020 of producing a ton of iron ore was $34. Just over $34. So you can all quickly do the math and realize that the margins on iron ore production are incredible. They are ludicrous. They were enormous back in May last year, and they are 2+ times as large now this time. And there at the top point there, 909 billion tons, that should say, sorry, not million tons. It is million tons. Stick with my million, stick with my facts. Nearly 1 billion tons of iron ore was produced out of Western Australia in 2020. So multiply 1 billion times the margin, and you can get an appreciation for the amount of revenue being generated by iron ore just in Western Australia, most of which, of course, is going to China. So all of that, when you think about that, you think about the amount of money being made, the pressure on producers to produce is enormous. And so what happens? A massive, to me, unacceptable mistake was made. And that was on the 23rd of May, only a couple of weeks after the conference last year. As we discussed about our concerns about would ESG slip, ESG didn't just slip, it collapsed in this particular case. And we destroyed 46,000 years of cultural history in one blast. So just a tragic, tragic event. And you can only imagine what the PKK people felt about that. But the whole ramifications that through accountability, organization, governance, etc., all of those things came to play. Rio Tinto suffered from top to bottom. And it was an unmitigated disaster. For me, it was I wouldn't say personal, because that's for the PKKP this was personal, but for me it certainly was very disappointing for two reasons. One, I used to work for Rio Tinto, and I still had friends working for Rio Tinto, and I was very disappointed. But secondly, I happen to have a very archaeological background, a father who was an archaeologist and a daughter who is now an archaeologist. So heritage to me is not something you play with. Heritage is critically important to humanity and to our lives and understanding of our history. So it hurt seeing this happen. And the question we have to ask is, have we learned from that? And I asked that, and I put that in the context of these rising metal prices, because it's not just iron ore now prices. Other things going up, particularly copper, is up to levels of 2010. And will that pressure to produce mean that we will sacrifice principles and values and our ESG approach to things. So I think I pose that to the audience and to the other panelists to think about. So the last thing I want to talk about very briefly is the critical minerals and metals space. And this is, again, has received some attention already in this conference. Peter Bryant touched on it in his talk early on in the conference. And so what are they? Just a very quick reminder, these are the critical metals and minerals we need for the energy transition. They drive electric vehicles, batteries, wind turbines, etc., but they're also highly important for many technical reasons. And they're critical because they have restricted supply. They're coming from countries that are not regarded as safe or politically stable, etc., have environmental concerns. They have complex supply chains that may be disrupted, etc. The important thing to remember on these is it's dynamic. A metal or mineral that's critical this year may not be next year because a new supply may appear and that may solve some of the problem. And so this dynamic aspect is illustrated in this slide, which is an EU slide with a periodic table, and it's color-coded by when these particular elements were critical, and it's changed between 2011, 2014, and 2017. And you can show the same slides, similar types of ones for the US, for Canada, for Australia, etc. In fact, the US just produced its update on Monday this week, obviously just to time it with this conference, because they thought that was the important thing to do. And so it's a very dynamic situation. It's important to also remember, although these are the critical ones because they are very special, even things like copper and aluminium are in immense demand because of for the same reason, because of electrification. These two elements, copper and aluminium, are absolutely vital in electrification. So that's driving the demand, whereas it's the battery technology story that's driving lithium, cobalt, nickel, manganese, graphite, etc. So important to remember that each one of these commodities is different. Their story is different, their location, the type of mine they come from, the extraction is different. The supply chains are different, and their recycling potential is different. So while we lump them together as this group of metals or minerals and call them critical, they're not the only thing. That's not the only thing about them. They all have very complex stories in their own right. So this week, interesting, again, another thing came out this week. This was the new IEA report called The Role of Critical Minerals in Energy Transition. And it's somewhat similar to the World Bank efforts over the last 3 or 4 years that have looked at the demand that will increase in these commodities as a result of the drive towards the energy transition. So a similar kind of approach, some different data, fantastic report, 230 odd pages of packed with data. And these are just a couple of diagrams, a couple of figures from that report. But I particularly like the quote, which I reproduced in the top left, which says, "The mineral requirements of an energy system powered by clean energy technologies differs profoundly," and profoundly is the key word here, "from one fueled by traditional hydrocarbon resources." And that's going to touch everything. And one of their key points on the bottom left is the supply chain in oil and gas, in fossil fuels, is quite dispersed and quite well understood. The supply chain in many of these minerals is highly concentrated, particularly by China. And this diagram on the left side of the diagram here, they talk about the mining side, which is, certainly China appears and DRC appears in terms of cobalt. But over here on the right, you can see the importance of China when it comes down into the supply chain in terms of processing. They are the dominant player, and geopolitics is going to be a very important part of our lives as we deal with that going forward. But the key message on these metals and minerals is we have to think of them in a supply chain context, not just in an extractive and resource context. And the slide on the right just illustrates their IEA's view of the amount of additional material that's going to be needed by 2040 for those key commodities to meet the sustainable development objectives of clean energy and so on. Again, very similar to the approach by the World Bank. Lastly, the point I want to make on this is people are thinking about new sources for these metals, and one that's come to light again after many previous iterations is the potential of the nodules on the ocean floor. And these are some pictures of the manganese nodules in the deep Pacific. And the area of focus currently is the central Western Pacific, the Clarion-Clipperton zone. And things happened in 2020-21. In fact, a lot happened in this space. And in the early 2021, GSR started some trial mining, and this is in the center of the picture is their vehicle that they dropped on the bottom. And then immediately thereafter lost for a short period of time. So they went fishing and recovered it. But so there's trial mining of these nodules going on as we speak. And then perhaps for me, even more surprising was that one of the other companies, Deep Green, managed to do a SPAC, which I hope many of you will have heard of, which is a way of raising an enormous amount of money on the market through a special purpose acquisition company, hence SPAC. And they have access to about $500 million here to proceed along this venture. The arguments made by these companies, and this is where it comes into the ESG space, is that extracting these metals from the ocean floor is better than land-based mining. Better because there's no communities, obviously, so there's not going to be any ESG issues with local communities, and countries with no resources are going to benefit from the production. But we have massive environmental uncertainties. Do we really know what we're doing down there? And will we ever be able to see what we're doing down there? At least in a mine on land, we know what we're doing well, and you can visibly see what we're not doing well. So there's a big question there. And clearly we need a lot more review in this space. So just to wrap up, so these are my post-pandemic thoughts, if you like, or sin-pandemic thoughts. The metal prices were off and roaring. And does that equate to increased performance risk? I think that's something we thought about that last year. I think we need to think about it again now. Mining industry supplies these critical metals, these things that we really need for the energy transition. That's really important. But we can't just in the mining industry so clap our backs, hands on our back, say we're great, we supply these wonderful things, and then do a poor job of providing them. Clearly, we have to have high levels of performance. We need some new sources for some of these things, some of the critical minerals I just talked about, but we actually need to focus on the full supply chain. We need to look at how we process these right through to the consumer, and the consumer needs to be a key part of that equation. And the focus needs to be unmitigatingly, absolutely on ESG, plus I for Indigenous. It's got to be unwavering in our efforts to try and meet the needs of communities, but also the needs of the industry, investors, customers, society, and so on. And that's going to require a lot of governance and change. And I don't see enough effort on the governance and change side of things yet to meet these questions that I just raised. So thanks very much, Sarah.
Brilliant. Thank you so much for that, John. So ladies and gentlemen, please put your hands together for the wonderful John Thompson. That was brilliant. Thank you. Now, as the questions come in, and I can see that they are beginning to come in now, which is great. John, just in terms of the deep sea mining, so obviously, the concept and actually people trying to enact mining underneath the ocean or on the ocean floor has been around for a while, but it kind of always grinds to a halt. Do you think this is actually going to be up and flying now, or do you think it's going to still take a long while for it to get going as an industry?
I think it's going to take a while, but a long while, I don't know. There are still many, many challenges and again, the challenges are not so much in how we pluck these nodules off the seafloor. The challenges are how do we do this environmentally in the most effective and benign manner, and that's just going to be a very difficult thing to establish from a baseline point of view and then act on and then monitor. So I think there's a lot of work there, and then I think we're the full supply chain from the seafloor to the customer is a wide open question. We still don't have really the processing route that clearly provides the metals in an efficient way. And the third thing that worries me a lot is the major element of the seafloor is manganese. It accounts for up to 30% of these nodules. We don't need as much manganese as that in the world. So if we start producing a lot of nodules, we're going to have a lot of manganese that we actually don't need now, unless we find some new use for it. And that plays into the economics of the whole exercise. So I think there's a lot of questions still. Obviously, it's moving right now, and a lot of things are going to come to a head quite quickly. And then how fast it really develops out as a sector, I think, remains to be seen.
Thanks for that, John. Yeah, we certainly don't need to be adding to that 72 billion tons of waste with a whole load of manganese that we didn't need to mine in the first place. Right. Second question for you here is, do you think, and this is a nasty question, so my apologies, given that the governments of the world have all been stating lots of lovely targets about net zero, etc., do you think it is actually possible for us to hit those targets given the supply-demand deficit?
Well, the question would be by when. I mean, if you're at 2050 targets, I presume they're the most kind of well-defined ones, questionably well-defined ones. I I think the resource issue is going to be not as dramatic a constraint, at least in terms of availability of resources. It's not going to be a dramatic thing. I think we have the resources. Will we be able to develop them? And this is where ESG becomes probably the key part, if not the Achilles heel of the question. Will we be allowed to develop them by communities and other peoples and jurisdictions in a way that's efficient and effective? So I see a lot of hick bumps on the road. I think we can get there by 2050, but it's not going to be a nice, smooth kind of linear growth curve. It's going to be very bumpy. And there's going to be a lot of big issues that we're going to have to deal with if we're going to get to producing that amount of material. And that's on the supply side. On the sort of development of technology side, there's a lot of work there to be done as well. So I am an optimist like you, Sarah, I know. So I hate to say it can't be done, because can't is a word that's not in my vocabulary, but it is going to be very difficult.
Brilliant. Well, thank you very much for that, John. Ladies and gentlemen, please put your hands together for the fantastic John Thompson. Brilliant. Thank you.